Welcome back, everybody. So let's continue. So you probably wonder why that is. It's really just a convenience thing. It's a convenience thing that it works this way. In fact, let me directly show you why. The reason is that then people can go ahead and write things like this. So you have a very large data set here, like millions of JSON objects, .name. So here you have a huge sequence of strings. And then you can write this huge sequence of strings equals Switzerland. And what that actually means is at least one of them equals Switzerland. So you test for the presence of Switzerland in that huge list, right? It's really just a shortcut. And it's very, especially by XML people, it's very appreciated to be able to do that kind of things because it makes the code shorter, right? So in that case, it's going to return true because at least one of them, so this one here, equals Switzerland. So this is true. Now here it's an example where it's false, but you know the negation of an existential quantifier, you know what it is? It's the universal quantifier. That's what you were about to say, right? It's the universal quantifier on the negated predicate. So the negation of at least one fulfills the predicate is none of them fulfills the predicate. So you would return false if whatever number on the left and whatever number on the right you choose, it will never be the case that the one on the left is greater than or equal to the one on the right. Can you convince yourself that this is true here? You will not find a single number on the left that is larger or equal than the number on the right. This is why it's false, okay? If you have strings, then you can return an error, but that was a very clever question that was asked before the break. We want to support lazy evaluation. Imagine that, in that case, imagine that these are sequences, there's a billion items in here, and there's a billion items in there. And you only so far looked at the first one here and the first one here. Do you agree that assuming that they all compare, you can already say it's true because it's an existential quantifier? You don't need to evaluate the rest, right? So with lazy evaluation, you can stop here and say it's true. But now imagine that there's a quintillion items in there that are all numbers. And then at the very end, the quintillionth and ones and the quintillionth first, you would say, is a string. So does it mean you cannot lazily evaluate anymore and you need to really check that there's no string anywhere? That wouldn't make sense, right? That would be a waste of resources. So in order to allow for lazy evaluation, you are not required to check the entire sequence for uncomparable values. It's totally fine to stop early and say that's true. So basically, if you have something incomparable, you can either return an error, or it would be fine to also return true if you would find a correspondence. The reason here why it's an error is that there is no correspondence. It would be false, right? So here you have to return the error. Okay. And then obviously, you know that the existential quantification on an empty set is false, right? It's just saying that you cannot find anything because there is nothing, right? So if you look at the empty set, you will not find anything in the empty set. So this is why when you have an empty sequence, it's going to be false. For whom is that clear? For whom is that not clear? Right? It's really just the law of logic, right? If you say there exists an element in the empty set that satisfies something, it's always going to be false because there doesn't exist any element in the empty set. For whom is that clear now? Right. Okay, awesome. Very good. So this is the typical use case. Then we have logic, and or not. That's the usual syntax that you can use in order to combine so that you see in many languages. Okay. By the way, if it's not a Boolean, if you use and, not, and or on things that are not Booleans, what happens is a bit similar to C++. Right? So a number that is 0, that's going to be false. A number that is non-zero, that's going to be true. A string that is empty is going to be considered false. A string that is non-empty is going to be considered true, and so on. So it's a bit flexible with something that's not a Boolean. Okay? So this is for arithmetics, for logic, and for comparison, right? We still with me? Okay, right now I'm just throwing at you the 37 expressions, right? And then you play the Lego game and assemble them. So what about that Lego game? So the idea is that you can just put any expression inside any other expression. That's basically the question you asked earlier, right? So whenever you have an expression, you can just replace it with an even more complicated expression, and it just works. Of course, it could return errors if that doesn't make sense, but syntactically, you can do that. For example, this here is a JSONic query. It's a JSONic expression. Now, if you want to make sense of it, you just need to evaluate step by step. 2 plus 2 is 4, thank you. So this is 4. Then we have A4 in an array and so on. Dot B, so that's extracting this B, right? So I replace it with the array. Then this array popped open, right? So now I can open it and extract the object inside. The object dot A, that's still a JSON query, right? That's 4. And then 1 plus 4 is, checking your following, 5, yes. And 5 to 50 is going to be a list of 46 numbers, 5 all the way to 50, right? Okay, who is with me? So that is how you compose expressions. You can put anything in any expression. And then you have to remember what you learned in primary school. If you try to mix multiplications and additions, you remember that multiplication takes precedence over addition, right? Who remembers this rule? Right? It's the early things you learn. Well, I told you that JSONic is just a big calculator. So it's just like plus and multiplication, and there is also some precedence between the expressions. Some expressions take precedence over some others. So this is the list of the precedence of the expressions. So those that are very low precedence, like addition, and those that are very high precedence, like multiplication, are at the bottom. Now, I don't know for you, I'm totally unable to remember that by heart, totally unable to do that. What do you do when you don't remember the precedence? You use parentheses, exactly, that's the solution. If you don't know, just put parentheses, then you're safe, right? You have full control over how that works, right? So you cannot have enough parentheses if you're not sure about the precedence. Okay, now what are the cool things that we can do with this Lego game? Well, for example, I can basically start writing something that kind of looks like a JSON object, except that at that point, it stops being JSON. That wouldn't be a JSON well-formed value, right? This is also not a JSON well-formed value. But what we did is we replaced the JSON value with an expression. We replaced here the values inside this array with an expression. I haven't explained yet what that does, although perhaps your intuition tells you what it does. But basically, this evaluates to 6, the length of the string. And this is iterating from 1 to 10, converting them to long integers, 64 bits. And then you populate the array like this. So you see that there is something dynamic in there. You dynamically compute the values that you then put in an array in here. You dynamically compute the value that you store in association with a key. You can even have dynamic keys. You can even replace the key with an expression. That also works, right? So any value you can replace with an expression. For whom is that clear? Right? Very good. And so this is how the Lego game works. You can just compose them in any way you want. Let me throw a few more expressions. They're going to be natural to you because you're all computer scientists. We have an if-then-else expression, right? It's obvious what it does, right? If whatever is after the if evaluates to true, then it's returning whatever the then expression returns. If it's false, then it returns what the else expression returns, right? So this is if then else. Then we have a switch, right? So you know the switch that exists in many languages, but it's a functional switch. It's not an imperative switch. So here, what happens is that it looks at that value and it looks for the first match, right? And as soon as you have a match, then you return whatever you have here. That can be any expression here. Even here, in fact, it can be any expression, and here too. Okay? For whom does that make sense? Right? The switch. If you don't want to remember the switch, you know you can do it with a cascade of if then else, right? So then just use if then else. I mean, you can also nest if then else's. But it's sometimes easier if you have a lot of if then else to just flatten it to a switch case. Just a bit easier to read than a cascade of if then else. Okay, then we have try catch. try catch is nice to catch like division by 0 or that kind of issues, right? All the dynamic errors, then you can catch them. And if that would return an error, then instead you just return that. Okay, for whom does that make sense? Right, you're computer scientists, so I assume try catch should be known to you. Just remember, it's functional. It's not an imperative thing, it's a functional thing. So the idea is that you attempt an evaluation of this. If that would result in an error, then you evaluate this instead. That's the functional way of looking at try catch. Okay. So let's get back to the queries then and do other cool things. So here we have JSON file, and then what I did is .payload.commit. So I basically picked inside at 2 levels down, inside the payload object, inside the commits associated with the commit key. Well, technically that's an array. I don't know if you, maybe it was if in the earlier slides, if you look closer, then you will see that what's at payload.commit is an array. So if we do that, that's going to return a sequence of arrays, right? But that's because my data set has always an array in there, right? So basically, that's a sequence of arrays. And these arrays contain objects. You can see some structure in there, right? So it's not a fully clean data set. It's not perfectly validatable against a schema because there's a bit of heterogeneity, but it's not fully heterogeneous either. It's kind of 98% homogeneous, if you want. So here you do see some structure. And so from the moment that you explore the data set and see that, who has this urge to unbox the arrays? Right? You have to unbox them. So let's unbox them. This is what it does, right? It's just going to extract the values. Now you have objects. And when you see a sequence of such beautifully similar objects, what do you want to do? .author, .email, and so on. And you can, in fact, do that, right? And navigate in this way, right? For whom is that natural to do these kind of things now? Right? Very good. So this is how it works. And then you can start doing more complex things. So this size function, that was the question you asked earlier, right? What if I want the size of an array, not of a sequence? Then you use size. So that would be an array, right? $.payload.commit, that's a single item. So that's a single object and that's a single array. And you call size, that's going to return the size. Now it checks if it's greater or equal to 5. This is the same thing as greater or equal. The only difference is that it doesn't like sequences of more than 1 items. So that's only in order to throw an error if it's more than 1 item. But anyway, I could have written greater than or equal as well. So that's a predicate that is only going to give me the objects for which the commits array has at least 5 items. Who agrees? Right? It's a predicate, and I want those that have arrays of at least 5 items in there. And then I count. And I can see that in that data set that has 2 billion objects, in that data set, it found 5,000 that have an array with at least 5 commits. Okay, so this is the sort of things you can do, and it just takes a few lines of code to do that sort of things. And you really need to understand, because you could think, okay, it's trivial also in Python, but really remember, it's the same code for a small data set of just 10 objects as for a data set with 1 trillion objects. It's exactly the same code. It's just automatically going to take care of it over Spark, transforming it to the appropriate transformations. Right. Okay, here's another one. What do we do here? Well, we navigate to payload commits. This is new, this one here. That is extracting the first item of an array. If it's only one that's of a sequence, the first item in a sequence, if you double the square brackets, that is the first one of an array inside the array. So here you look at the first commit, and you look at the email of the first commit, right? And now you look at the distinct emails, and you look at how many distinct emails were in the first commit of any one of the GitHub events, 34,000. Who understands that query? Okay, very good. Do we have a question over there? Yeah.
Could we also put the square brackets one after the outer square brackets? Would it be the same?
Yes, absolutely. You can also, if that didn't exist, you could also use the double square bracket to open the array. And then you could use this square bracket one to then take the first item in the sequence, because when you open an array, it becomes a sequence of more than one item, often. What's the difference? The difference is that when you use this unbox operator, if the left contains more than an array, you could have a million arrays, and then you unbox, it's going to unbox each one of the million arrays and then flatten, right? Then if you do the position one after the unboxing, it's really just going to return the first item in the first array. If, on the contrary, what you do is you have your sequence of a million arrays and then double square bracket one, it's going to return the first item of every array. That is the difference between the two. It's a subtle difference. If, of course, you only have one array, then it's the same. If you know that there's only an array, you can use one or the other. Does it make sense? Yep. And again, the key is to remember the sequences are always flat. Whenever you do something that produces a sequence, it's always flattened. So if you do lookup, if you do array unboxing and so on, always, 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 you get a flat sequence. And the way to nest is with arrays. This is how you nest. Okay. Did that address your question? Awesome. That's a very good question. It's nice to think, trying to relate these with each other. Now, something else that I haven't shown you yet. Who has already seen a functional language before? Who has already seen a let clause? Okay, it works in the same way as in many functional languages. The key part is to understand that this is not a variable assignment. It's not like in Java where you assign a value to a variable and then you assign it a different value and so on. That's not this. This is a mathematical construct. This should be interpreted as, give me the count of the distinct logins, knowing that the distinct logins are the distinct values of logins, knowing that logins is the login of the actors, knowing that the actors are the actor of the events, knowing that the events are in that JSON file located at path, knowing that path is git archive big JSON, right? This is how it's interpreted. You just declare some variable values, and that's just a way of making your query easier to read, right? By dividing your expression into several parts, right? For whom is that clear? Right, very good, cascade of lets. Now what's really cool is that we don't only have lets, we also have fors. And the fors are going to iterate. The magic lies in the understanding that everything is a sequence of items, and as a consequence, you can iterate over a sequence of items. So it means that if you have here a million items, then you can just in turn bind this variable to each one of the item one by one. And for every item, then you do the rest. So for every event, you're going to evaluate the number of commits, just the size of the array, and then you return that object. But since you have the for, it's going to return that object for every event that came from the Git archive, right? And that's how you basically transform or map this original sequence of objects to another sequence of objects. Notice here, it's dynamic. I have an object constructor, but this is dynamic here. It's returning some calculated value and some calculated value, and you see the results in here. For whom is that clear? Okay. Now, there is one thing you need to notice here, is that if you use an object constructor like this syntax is a bit static in the sense that the number of keys is defined at compile time. It's in the syntax. You have two keys, and you cannot make it dynamic, the number of keys. It's really something, comma, number of commits. You could make the keys themselves dynamic, but you cannot make the number of keys dynamic. It has to be two, because there's only one comma in there. Yes?
Yeah, so wouldn't you get the same thing if you just, I don't know, took the filtering like you did usually with the square bracket? So you would not even need the for loop here, right? Because like every query language does automatically for loop through the rows, right?
So you could, if you would use a predicate, that would also be an iteration, but that iteration would select a subset of the original collection. Then if you continue to navigate, that would also just take a subset. You would be unable to create new objects. what you need to understand here is that we want this output in here. These objects here, they are really new. They are created by the query. They cannot come from this data set in here. They have to be created. So this is why we need to have an explicit construction of these objects in here. That would be the difference with using a predicate. Does it make sense?
Yeah, so is it like the same as in SQL when you have like in the select query where you put like
Yep.
like some calculation?
I got your question now. Yes, this here is like a SQL query where this is the from blah, blah, blah. This is select ID number of commits. More precisely, it would be select ID as ID and then NB commits as number of commits, right? So you could see it as the select clause in SQL. But in SQL, you do not have let clauses. That is one of the...
Right, like with, isn't that let clause also?
Well, you can use the with construction, but it's not. It would be a let clause on the entire table, the with basically. But here you don't want the let to bind to the entire collection. You want to do it for each event. So it's more fine-grained than the with of SQL. That's basically the idea. And so this is really this let clause is one of the features that you get in these NoSQL query languages that you don't have in the original SQL language that really processes the whole table. And the reason why we like these let clauses so much is because of heterogeneity. Basically, when you have a homogeneous relational table, you can do without the let clause, kind of, for many cases, because it's all homogeneous. But as soon as you have something heterogeneous, then you really appreciate the let clause because that allows you to do something different on every event. Does it make sense? Right? But it's a very good observation indeed that this corresponds to a from clause in SQL, and this corresponds to select, and this would correspond to the projection. That is absolutely correct to say it that way. It's just the let that doesn't map to SQL. Right? Okay. Okay, which brings me to how does this let and this for generalizes to something bigger? And this is something called the FLWOR expressions. FLWOR expressions are in fact an abbreviation for, you guessed it, for let, where, order by, return. FLWOR, and it's on purpose. There's no spelling mistake in there. I think it's probably a hint to one of the very early inventors of even X-query is Dana Florescu, and so that's probably the origin of this choice in here. Right, as a recognition for her work. So the let clause, this one is easy if you remember what I told you. We just want to return x times x, knowing that x is 2, and then we get 4. Okay, who's with me on this one? This is an easy one, right? Now, this is a simple for return. We just bind x to every integer between 1 and 10, and for every one of these 10 integers, we return a new object. We return a new object with x as the number and x times x as the square, and we get this. Who understands what's going on here? Very good. So you see, this is how we map a sequence to another sequence in this way. The where clause can appear in the middle between for and return, for example. It acts as a filter, but you need to be very careful on the subtle distinction with the kind of filter that it is. I'm not talking about a filter like the predicate expression that filters the items on a sequence. This is not what we are doing here. Here, I'm really reasoning on variables. I'm iterating for x taking values between 1 and 10, and I throw away some of the variable bindings. I'm throwing away the bindings of x where this is not true. So it means that if you look, it's basically only keeping x equals 8, 9, and 10, right? That's the only survivors. It means that all the x's between 1 and 7 get lost at that point, and only 8, 9, 10 survive, leading to these 3. Who understands that? Right? Intuitively, it's the same as the where in SQL, but we will see that FLWOR expressions are in fact much more generic and powerful than the select from where, right? But I will come back to that. So this is the where clause. This is the order by clause. So this is reordering the bindings, right? So here you bind X in turn to every object in that JSON lines file. And then you reorder by population, and then you return the name, right? And then you get this list on the right of the most populous countries in the world. Okay? Who understands the query? Who doesn't understand the query? Who understands the query? Okay, that's great. Again, it's like the SQL order by, right? In effect, it's very similar. Then I have group by. Group by, again, it's just like the SQL group by. Look at what happens here. I'm binding X in turns to every country in the world. I'm assuming I have the, well, there's not millions of countries. There's actually just around 200 or something, but let's pretend it's huge. So we have an iteration over the countries grouped by continent. Here, I'm only going to have, depending how you count, let's say 6 of them, right? 6 continents. I'm grouping them. What is happening with a group by? This is something that is slightly different than SQL and in a great way, in a more generic way. What happens is that this continent here is a grouping key. So just like in SQL, it's going to contain the current continent. What's very interesting is that the $X becomes a sequence of all these country objects within the same group. It becomes a sequence. And that is with the magic of the sequences of items that we don't have in SQL. So that's why we can't do it in SQL. But what happens is that now, after the group by, I'm going to have 6 groups, 6 bindings. And for every one of these 6 bindings, I return that. So the code is the continent. And look at what happens here, $X. What does it return? Always a sequence of items. Any expression returns a sequence of items. Which items? The ones that correspond to the current continent. And if I do .name, then I'm just listing them. Who understands this query? Right, very good. And cherry on the cake, I nested it into another query, meaning that I even put that inside an array, which is itself inside an object. But since it's a Lego game, I can do all of that, right? So you see how at the same time, it kind of takes over what SQL does, but in a more generic way, in a much more powerful way. There is a reason for that, is that the people who designed that, this FLWOR expression, it's not actually just JSONic, it's also XQuery, it's a W3C standard. And many people in the working group that designed the W3C standard were also involved in SQL. The chair of the working group was an editor of the SQL standard. So this is why it's not a coincidence that this is more powerful than SQL, because these are the actual SQL people who learned from the experience and generalized the SQL firmware idea to something more generic. Now, what do I mean with more generic? So this is one example that this group by is more generic than in SQL because you can have sequences for the non-grouping keys. But there is something else that is more general. Who remembers that in SQL, the clauses must be in a certain order? Do you remember? Select from, everybody, select from, where, group by, having, order by, limit, offset, right? It has to be in that order, not so in XQuery or JSONic. There's a few constraints, such as it has to start with for or let, and it has to end with return. In between, whatever you want. Absolutely whatever you want. You can have, for example, for, let, where, group by, let, for, order by, let, for, where, group by, let, where, order by, for, return. That is an absolutely fine FLWOR expression. So you see how it's more generic than SQL, right? And that's extremely powerful. And once you get the intuition of FLWOR expressions, you can write extremely powerful queries in a way that is more compact and intuitive than would have been with SQL in the presence of heterogeneous data. Okay? Who is with me? All right, very good. I keep asking because I'm throwing so many things at you here that I really don't want to lose you. But again, the best way is to practice, right? You have Jupyter notebooks, you have an engine, you can just go ahead and execute queries. That's really the best way to learn. And of course, there is the textbook that has plenty of example queries as well. Now, what if I want to be a bit more formal? Because so far, I told you what these FLWOR expressions are doing, but I just waved my hands, right? I said, okay, let is this knowing that. For is you iterate over values, where you throw away some bindings that don't pass a predicate. But I just waved my hands when I explained that. So how do you make it make sense when you have a FLWOR expression that has 20 clauses that are an arbitrary sequence of clauses? How do you make sense of that? And here you need a mathematical formalism. It's a formalism that you do not have in SQL, because you do not need it in SQL. And the reason you do not need it in SQL is that in SQL, it's always the same order. That's why you don't need it. But in a language like JSONic, you do need it. You do need a formalism for the clauses. And in fact, what I hope to show you is that that formalism, first, it's very intuitive. It's really a flow that goes from the top to the bottom of the query, right? So it's just flowing down. With variable bindings. But normally, if I got it right, I'm going to not tell you in that way, but if I got it right, you should see in your minds data frames and Spark SQL transformations or data frame transformations. So now I'm going to see if you see them. If you don't, then I will explain. But hopefully you will notice that there is a link with SQL data frames. So if I want to now formalize something like this, what I need to do is go clause by clause from the top to the bottom, right? So I start with the for clause. So the for clause is going to bind the variable x to every item in that sequence. How many of them? 10. The way you can visualize it, that's only a visualization, is that there is this x that is then first one, then two, then three, then four. So you have the list of all values that is going to be bound to, right? I'm just putting my list in there, right? So far, so good. This is a plan. It's all the bindings I can do between 1 and 10. Then I move over to the second clause. That's a where clause. So it's a where clause. So what happens is that we have this thing here. It's an expression that needs a value for x. So it depends on x. And it's going to evaluate to true or false. So what happens when the where clause is evaluated? It's basically evaluating this expression for every one of the rows in there, every one of the values. So now, if you compute x minus 2 greater than or equal to 5, you will find that it's false, 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 and then true, 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 right? For example, 8 minus 2 is 6, so that's greater than 5, and so on. Who agrees with that? Right? And now you have this array of Booleans. So now I'm going to do it pandas style because some of you appreciate pandas. So if you now feed that array of Booleans that has the same size as this series, then you get that sub-series, right? But what's beautiful here is that it's implicit. That is nowhere in JSONic. In JSONic, you just write that directly. It's very intuitive. Even people who don't visualize this in their head might still find it intuitive. That is just the formalism when you actually do it in that way. And then you get 8, 9, 10, and then you evaluate x times x for every one of these, and then you return it, so you have again the sequence of 3 integers. For whom is that clear? Right? That's generic. Any FLWOR expression is evaluated in that way. You go clause by clause, and you just process the variable bindings in this way. And now I hope that you see that when in pandas, you expose the user to doing this, that you actually have in Python this list of Booleans that you feed into the list of integers. That's a breach of data independence. You're basically forcing the user to deal with that, but in a functional query language, you hide it from the user. This is all hidden. This is just hidden behind that query over here, right? Okay, but if you know pandas, that's useful because then you can kind of map it in your mind to this. Here's another one. Let's do it. For x1 to 5, that's what you get, right? What does the let do? Oh, there's another variable. Let's just add a second column in there, right? It's x minus 2. So you see 1 minus 2, that's minus 1, 2 minus 2, that's 0, and so on. Who is with me so far? Right? So that's the let clause at the second column. And then return x times y. We just multiply x and y on every line. Again, all of that, what you see here, is a mathematical formalism. It doesn't pop up anywhere in the sequence of items and so on. It's just an internal formalism. That's what pops out. Oh, that's what pops out of the FLWOR expression, what you see here. And that is only a visualization, only a visualization. But how many of you feel like this is starting to look like data frames in here, right? And in fact, what it means is that physically, and I insist on physically, you can implement this as data frames. And that's exactly what RumbleDB is doing. Internally, but in a way that the user doesn't see, it's actually going to create these data frames. But do you see that because it can create these data frames, it can create these with billions of rows. So it means that RumbleDB can compute that with billions of bindings in parallel on a Spark cluster, because internally it's modeling that as data frames. Who understands that? Right? Very good. But again, it's physically. The user doesn't need to know about that. It's all hidden from the user. It just works. All right. What about group by? So let's do the same here. For x 1 to 5, you get that. What does the group by do? Well, first you need to evaluate the grouping key for each one of them. So that's 1, 0, 1, 0, 1. But now we need to have the group by. What does it do, the group by? It's going to figure that these go together. 1, 1, 1, they are together. 0, 0, they are together. And when it does the grouping, it does this. And this is something you don't have in SQL. So it has this, I need to put myself on the other side. Otherwise, I keep operating and disapparating. So y and 0, these are my two groups. But do you see what happened to x? It's just now a sequence, because yes, we support sequences of items. It's a sequence of 1, 3, 5 when evaluated in conjunction with y equals 1. And it's the sequence 2, 4 of 2 items when evaluated in conjunction with y equals 0. For whom is that clear? Right? So this is how you visualize the group by. And then when you create that object, you just evaluate this with y and x taken from here. So you do a first evaluation with x being this and y being this, and then you find this. And the second evaluation with x being this sequence and y being this singleton sequence, and then you get this. For whom is that clear? Right, so this is the formalism. And again, if you understand the formalism, that's great. For most users, they don't even think of the formalism. It's just intuitive. They have an intuition of how it's going to work. So yes, that's the formalism of FLWOR expressions. And hopefully now, if I give you an absolutely gigantic FLWOR expression with 30 clauses, with a mix of all kinds of clauses, you should be able to draw these visuals and go down clause by clause how it computes the values. Okay. All right. Okay, so now if I go back to my geeky views here, I can have now an example with 4-let order by return. That's a perfectly fine combination of clauses. So you see, for every event, I compute the number of commits. I order by the number of commits descending, just like in SQL, I can specify descending. And then I project. So here I need an explicit function to project event to just ID and type. So I just take the ID and type keys, and I have ID here and type here. And this is what I'm getting. So this is an example of query. This is an example with group by. So now I have 4 group by, order by, return. In fact, in that case, it happens to be an order that you could also do in SQL, right? But again, it's more generic. But in particular, you can do what you can do with SQL. So 4 group by, order by, return. Here, you group by the size of the commit, right? And then you order. So you have 0 commits, 1 commit, 2 commits. This is basically a histogram here, right? I'm doing a histogram by the number of commits. I'm looking at the events. How many commits do they have? I group them, and for every number of commits, I say the number of events, right? Who sees that this is a histogram? Okay. So, yeah. And you might have noticed some trick right here. Why do I have this size, blah, 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 then 0, and then I take the first one? It's a trick. Because this array might not exist. That's because it's NoSQL, it's JSON, it's not necessarily valid against the same schema. The commits might not exist at all. In that case, that's going to be empty. that's also going to be empty. And what happens is that empty concatenated with 0 is just 0. And then you take the first one that's going to be 0. So this is a trick to just, if it's empty, then you take 0, right? So this is the sort of things you can do with a language that deals with heterogeneity, right? You could also have done it with an if then else, like if empty, blah, 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 but this is just more compact to do. All right. Still have 5 minutes. Can I still throw some queries at you? It's nothing new. It's things you already know, but I just show you how you do things in JSONic. So imagine that now I have 2 data sets. To simplify, just a few products in here and a few stores, knowing that the store here is a foreign key that points to the ID of the store here. So there's a link between these 2 data sets in here. And what I want to show you is that all the relational algebra, we can do it in JSONic. So this is a select from where, for where return, that just only picks the ones that have store equals 1. This is a projection. So here you need to use the project function to ID and type. By the way, you can do a dynamic projection. If you replace that with an expression, you can dynamically create the keys that you project to. It's also something SQL cannot do. And then you have ID and type in here. So that's a projection. Ordering, you just use order by, that you already know. I'm ordering by ID. That's nicely ordering like this. Then you have aggregation with group by. I've already shown to you, right? If we group by type, then I'm going to have PV phone and teapot, and that I aggregate here. Notice that here would be doable in SQL, because even though this now is a sequence, I immediately take a count. And that in SQL you can do. If you immediately aggregate, immediately take a count or a sum or a mean or a max, then in SQL you can do it, right? So you can see that in particular, it can do what SQL can do. Joins, probably my last slide before I let you go. For a join, I just need a double for. Double for would do the Cartesian product. Who sees that? Double for is the Cartesian product, followed by a where clause that has my joining criterion. You remember that a join is basically a Cartesian product followed by a selection, right? We have a question over there. Sorry? It is efficient, because RumbleDB is going to figure out that it's a join and automatically do it fast. That is the benefit of data independence. That's the benefit of a functional language. As a user, you can write this absolutely beautiful query that is easy to read, and it is going to be executed very fast. Just because it looks simple and plain doesn't mean it's going to be slow. That is the difference with Python or Java or an imperative language, right? To whom does that make sense? Right, great. That's an excellent question, because this is very important to understand. This is efficient, very efficient. All right, should we stop here? Then maybe I can continue tomorrow. So I'm almost done. Tomorrow, I will mostly give you implementation details, like what's the internals of RumbleDB, how it's all implemented, the beautiful work by the 20+ students who have been working on it in the previous years. So thank you very much, and see you tomorrow.